Alright, it's time to run a brief overview on caffeine, another psychoactive drug, because a ton of people use this drug, every day. Almost everybody does. But a lot of people might not actually understand it. So I just want to do a little brief overview on it because I find it super cool, super interesting. So let's just get right in. So here's our table of contents. This is just what we're going to be going over. Is what is caffeine, its effects on the brain, caffeine and sleep, and then benefits and drawbacks. So what is caffeine? Caffeine is obviously a stimulant, as we all know, and it's a part of the methylxanthine family. I don't know if I said that right, but I'm just taking a guess. And this is like a very interesting family of stimulants because they don't work in the same way as other ones like amphetamines and stuff. But anyways, here we have caffeine and then theobromine, which, if you don't know, is a stimulant found in chocolate. And then right underneath I have adenosine triphosphate, which we'll talk a bit more about later, but pretty much ATP is obviously energy. But the adenosine here, you might see this part shares a lot of resemblance to caffeine and theobromine, which we'll get into and kind of highlight more on that later because it connects to how caffeine actually works. So the effects on the brain. Caffeine is an adenosine receptor agonist, meaning obviously here's your adenosine, and caffeine is going to attach to your adenosine receptors, which is going to, plays a role in energy metabolism, and your sleep-wake regulation. That's pretty much what adenosine is responsible for. And here's your adenosine cycle during the day. So obviously in the morning it builds up throughout the day, and then it gets to a point where you're feeling super tired because that's what adenosine does, and then you sleep, and then it starts the cycle again. So this is actually a little graphic I made on how it works. So here caffeine is, and caffeine is going to bind to the adenosine receptor, which I just put as AR for short, not to be confused with androgen receptor. Caffeine is going to bind to that adenosine receptor, and adenosine is going to be blocked from binding to the receptor. So your adenosine will be rendered kind of inactive, and caffeine has its main effects by actually blocking adenosine. So you don't feel tired and you don't feel the effects of it. And so that will promote awakeness, alertness, and then you also get slight increases in norepinephrine and dopamine, but it's nowhere near close to amphetamines, especially for the dopamine increase. So this is just another thing I want to talk on is now what happens after that caffeine binds to the adenosine receptor. And so here's the same graphic. Caffeine binds, adenosine is not doing its job, so you're blocking the tiredness. Your body is going to want to maintain homeostasis, and I kind of highlight this on my other nicotine video, but homeostasis, this is the brief definition, the self-regulating biological process of maintaining a stable, relatively constant internal environment despite the changes in external conditions. So caffeine is obviously going to be that change in external conditions. And once you take this psychoactive drug and it acts on the adenosine receptors, your brain knows that adenosine is not doing its job, so it's going to upregulate adenosine receptors to try and make room for the adenosine so it can start doing its job. And what that leads to is stuff like caffeine tolerance, and then obviously withdrawal, because your adenosine receptors are going to be upregulated more than usual. So if you were to stop, you'd get withdrawals. And then also you need more caffeine to cover more adenosine receptors. And upregulation, by the way, just means more adenosine receptors will be created. Now, caffeine and sleep. This is a very brief one, but the half-life of caffeine is known as 4 to 6 hours, which the half-life kind of just means how long does it take for half the dose to clear out of your system. So, just an example, a coffee at 3 p.m. Could still leave around 50% of caffeine in your system by 9 p.m. And caffeine reduces slow wave and REM sleep and will delay melatonin release. So it, since it's a stimulant, it will obviously mess up your sleep. You won't be able to fall asleep as fast, and you won't get as deep of a sleep. Now, benefits and drawbacks. I kind of just highlight the benefits here because I think the drawbacks are kind of, they're very slim, but I already kind of went over them. The drawbacks are obviously withdrawals, and then, potentially interfering with your sleep. So here's the benefits that it actually has in physical performance. Improves endurance by mobilizing fatty acids. It increases adrenaline or epinephrine, which is this neurotransmitter. And then it can delay fatigue in both strength training and cardio. So it is definitely a performance enhancer, and a pretty strong one. And that's pretty much it. Just super short, super brief. I hope you guys learned something, and thank you.